Hey there. So this video is not specifically about Microsoft and its shenanigans, shall we say. But in a way, Microsoft is involved. Well, really not just in a way, sort of directly. But to get to the point, a friend of mine, a good friend of mine, reached out to me recently and asked that I take a look at a document called The Decade Ahead from a group called Situational Awareness. A document written by, I believe, the founder of their organization called Leopold Aschenbrenner, written in June of 2024. And the document purports to be a prediction or a projection of what's going to happen with AI. Now, there are a lot of documents like this. People seem to be coming up with predictions all the time. And even though everyone has their own spin, the destination is often the same, which is, machines are going to be smarter than us, and look out, here we go. We have a big problem of some sort. So I thought I would just kind of go through this document because it not only gives us an opportunity to look at this specific example of what I'm going to call AI hype, it also, I think, will help walk you through how to engage, from my perspective, with these kinds of documents. These documents benefit from the fact that in our society, there is a bias towards the concept of progress and the notion of some kind of better future. But they tend to be light on details, but very long on hyperbole. But enough preamble, let's actually take a look at the document and go through how to think about these things. I'm going to start by reading the first paragraph of this document and just see what occurs to me. I'm reading this pretty much fresh, so you'll get my first impression. So let's start. Situational Awareness, The Decade Ahead, Leopold Aschenbrenner, June 2024. You can see the future first in San Francisco. Over the past year, the talk of the town has shifted from $10 billion compute clusters to $100 billion clusters to trillion-dollar clusters. Every 6 months, another zero is added to the boardroom plans. Behind the scenes, there's a fierce scramble to secure every power contract still available for the rest of the decade, every voltage transformer that can possibly be procured. American big business is gearing up to pour trillions of dollars into a long, unseen mobilization of American industrial might. By the end of the decade, American electricity production will have grown tens of percent. From the shale fields of Pennsylvania to the solar farms of Nevada, hundreds of millions of GPUs will hum. Now, right here, in the beginning of the document, we see a problem. Although this is presented to us as if it's some sort of remarkable development, what we are actually talking about is the ramping up, according to Aschenbrenner at least, the ramping up of orders of magnitude of more electrical power simply for the purpose of powering data centers to host AI and really large language models. But let's continue. The AGI race has begun. Now, here, of course, what's AGI? But let's go forward. We are building machines that can think and reason. By 2025-26, these machines will outpace many college graduates. By the end of the decade, they will be smarter than you or I. We will have superintelligence in the true sense of the word. Along the way, national security forces not seen in half a century will be unleashed, and before long, the project will be on. It's interesting that the project is capitalized here. If we're lucky, we'll be in an all-out race with the CCP. Oh, so of course the concern is China. If we're unlucky, an all-out war. I'm going to pause right here because, again, many things are kind of mashed together here, aren't they? AGI, which is not defined, so we're just supposed to assume that we know what it is, and that's because Aschenbrenner no doubt knows his audience. Artificial general intelligence is what that stands for. We are building machines that can think and reason. Okay, by 2025, 26, only a year from now, will outpace many college graduates. Perhaps not all, maybe not the super clever, but certainly the average college graduates. And by the end of the decade, they'll be smarter than you or I. Now, of course, what's missing here is a definition of what that smartness is. Like, for example, will these millions of GPUs powered by shale farms in Pennsylvania, will they be able to do dentistry for you? These are the kind of questions that occur to me when these large statements are made. And then there's the geopolitical element, which I find quite interesting, because if superintelligence is unleashed upon the world, what role do geopolitics play? And why China alone? Interesting. All right, let's proceed. Everyone is now talking about AI, and this is true, but few have the faintest glimmer of what is about to hit them. NVIDIA analysts still think 2024 might be close to the peak. Mainstream pundits are stuck on the willful blindness of it's just predicting the next word. They see only hype and business as usual. At most, they entertain another internet-scale technological change. Now here, what Aschenbrenner is doing is poo-pooing people who, including NVIDIA, mind you, the actual manufacturer of some of the most popular processing units for this technology. He's saying that they're wrong. These people are wrong. Mainstream pundits are stuck on the willful blindness of it's just predicting the next word. Now, let me show you something about that. When he says they're just predicting the next word, he's referring to the work of people like Jay Allenmar, who described in detail how large language models work years ago. In other words, they are text predictors, and this is a known element of how these things work, right? In fact, Aschenbrenner, or rather, Allenmar did a really lovely video. In which he talks about how these things work with animations, which you can see here, and I'll include links to this later. This is a machine, and it does work according to machine principles. It's not something that was simply created whole cloth. Anyway, let's go back to the document. Before long, the world will wake up, but right now there are perhaps a few hundred people, most of them in San Francisco and the AI labs, that have situational awareness. How interesting. These are like the high priests, aren't they? Through whatever peculiar forces of fate, I have found myself among them. A few years ago, these people were derided as crazy, but they trusted the trend lines, which allowed them to correctly predict the AI advances of the past few years. Do we get examples of this? Well, let's see. Whether these people are also right about the next few years remains to be seen. But these are very smart people, the smartest people I have ever met, and they are the ones building this technology. Perhaps they will be an odd footnote in history, or perhaps they will go down in history like Szilard and Oppenheimer and Teller, the inventors of the atomic bomb, or as physicists, I should say. If you've seen the Oppenheimer movie or you know the history of the Manhattan Project, you should know who some of these people are. If they are seeing the future even close to correctly, we are in for a wild ride. And let me return for a moment to this comparison that Aschenbrenner makes between the creators or the physicists who orchestrated or participated in some form, in the case of Oppenheimer, as the lead scientist and project manager and overall lead, and Szilard in terms of his contributions to atomic physics, theoretically, and of course Teller, who is known as the father of the hydrogen bomb or the fission-fusion cycle. He is comparing these individuals who created weapons that still vex us to this day to the individuals and the teams and the companies, including himself, mind you, who are orchestrating so-called AI. Let's go on. Let me tell you what we see. So here is the table of contents of this this statement, and the website is situational-awareness.ai. I won't go through all of these, but let's take a look at some of these headlines here. From ChatGPT-4 to AGI, counting the OOMs, orders of magnitude. AGI by 2027 is strikingly plausible. GPT-2 to GPT-4 took us from preschooler to smart high schooler abilities in 4 years, tracing trend lines in compute. 0.5 orders of magnitude of OOMs, that's orders of magnitudes per year. Algorithmic efficiencies, 0.5 OOMs per year, and unhobbling gains from chatbot to agent. We should expect another preschooler to high schooler sized qualitative jump by 2027. Now, this is an extraordinary statement, because if I say that an entity or machine has gone from preschooler to smart high schooler abilities, what am I talking about? How am I defining this? What are the metrics? Preschoolers can walk around in the world, navigate the world, understand many, many, many things. But what do these machines understand? Let's actually click on this and take a look at it. AGI by 2027 is strikingly plausible. We've already read this particular intro, so let's go forward. Look, the models, they just want to learn. You have to understand this. The models, they just want to learn. Ilya Sutskever. This is an interesting quote. This is very interesting, rather a well-known person in this area, or in this field, I should say. And note how the large language models or machine learning models are described as having agency. They want to learn. They're not software. Now, no one would have described, say, Microsoft Exchange as a product that wanted to send email. When you were dealing with a product like Exchange or SQL Server or other complex bits of software, you never described them as wanting to do something. You understood that they followed their instruction sets and did those things, usually correctly, sometimes not, based upon the instruction set, right? So let's go forward here with this particular line. GPT-4's capabilities came as a shock to many. An AI system that could write code and essays, could reason through difficult math problems and ace college exams. A few years ago, most thought these were impenetrable tasks. But GPT-4 was merely the continuation of a decade of breakneck progress in deep learning. A decade earlier, models could barely identify simple images of cats and dogs. 4 years earlier, GPT-2 could barely string together semi-plausible sentences. Now we are rapidly saturating all the benchmarks we can come up with. And yet, this dramatic progress has merely been the result of consistent trends in scaling up deep learning. So, the argument here is that scale is indeed all you need. If you just keep scaling, you keep getting better results. What's missing here? What's missing from this particular assertion? Well, I will tell you. As is covered here in this Inc. story, a group of workers for a Silicon Valley unicorn, as they describe it here, with a reputation for fleecing workers abroad, is behind the AI startup now seemingly doing the same in the US. What this article is about are a group of workers who actually, behind the scenes, were refining the results. In fact, the first paragraph of this begins the story. In February, Emil Friedlander, a journalist in New York, received a LinkedIn message advertising a new job with the potential to earn up to $40 per hour, $1,600 per week, while teaching AI models how to write. Now let's go back to Aschenbrenner's statement, saying that this is merely the continuation of a decade of breakneck progress in deep learning. And he even gives us this nice looking chart here that shows the level of compute and then the capabilities, allegedly, of the models, rough estimates of past and future scale up. And yet, behind the scenes, what we learn, if you pay attention to the actual business, and this is a business we're talking about, if you pay attention, what we learn is that behind the scenes, there are people making these models work the way that Aschenbrenner is attributing to simply progress based upon scale. In fact, Aschenbrenner creates this metric, the order of magnitude times equal order of magnitude, which sounds great. It sounds very mathematical. Sounds like something that perhaps Teller or Oppenheimer would use, but he's just sort of applying this to his argument to make it seem a bit more scientific. Going back to the article, Friedland received 3 more recruiting messages on LinkedIn from Outlier. The pitches seemed automated, Friedlander explains, and they appeared with a sponsored tag. There was something about it that felt predatory. The main point about this article, which again I will share with you, is that these are workers whose job it was to refine the particular model used by this organization. Now, OpenAI does exactly the same thing when they refine a model, when they refine the output of a model. And so there's nothing particularly unique about what this company is doing, and OpenAI has been accused of much the same thing. Going back to Aschenbrenner, while the inference is simple, the inference between his order of magnitude and performance, the implication is striking. Another jump like that, like the kind of jumps he's talking about in this chart, another jump like that very well could take us to AGI, to models as smart as PhDs or experts that can work beside us as co-workers. Perhaps most importantly, if these AI systems could automate AI research itself, that would set in motion intense feedback loops. And this is the old idea of the singularity, in which machines begin to build machines and engineer new machines, and there's a kind of accelerated loop, as Aschenbrenner is saying, an accelerated loop that produces machines that are so advanced that we can't possibly understand them. What is missing from this? What is missing from what you're seeing here? There's a lot of breathless statements. There are many breathless statements, I should say. There's a lovely chart, and there is a mathematical sounding term, the OOM. But what's missing is an actual description of how this could be accomplished, what the actual mechanics are. So here we have that GPT-2 is a preschooler. This is asserted, but how is it actually defined? What is the knowledge of a preschooler? The only example that we're given here is sentences, as if the entire the sum total of what a preschooler knows and how a preschooler engages with the world is through language alone, or the ability to string together sentences. When, of course, preschoolers, like all living things, interact in with a three-dimensional world. And Aschenbrenner goes forward and basically is saying that, you had GPT-2, which was at a certain level, and then gives some examples of text that GPT-2 was creating, and then GPT-3, and then says that it's at the level of an elementary schooler. Again, this leads to the question, I'm hoping children, or have known children who are at this level, is the only thing a child can do is respond to a prompt. And then, of course, GPT-4, which we're told that has reached the level of a smart high schooler. This takes me back once again to how these things work, right? How do they work? This is what's missing from these charts and from these graphs and from these statements. And then, of course, we get this really great chart that says, well, GPT-2 preschooler, GPT-3 elementary schooler, GPT-4 smart high schooler. Again, with no actual comprehensive definition of what this is supposed to be. Like, what is the scope of knowledge of a preschooler typically? What is the scope of knowledge of an elementary schooler? And so forth and so on. It's simply a kind of an underpants. The more underpants you get, the better you are, if you're familiar with that joke. Again, more and more charts, to demonstrate, or rather to illustrate Aschenbrenner's point. And these test score results are interesting because there have been examinations of benchmarks of the application of language models to tests. And of course, the most easy thing to ask, or the easiest question to ask, is, well, how was that done? In other words, if the answers to a test are available to a large language model, and then you input the test, the series of prompts, or rather the questions of a test, as a series of prompts, why are you surprised that it's able to output plausible sounding answers to those questions? We also don't know to what extent the companies who do these tests, to the extent to which they're cheating. Again, I get back to this story, and there are many other such stories, and so forth and so on. So Aschenbrenner gives us examples of Sora here and how Sora has improved, but of course there are stories about Sora and the fact that Sora's source, or rather the source, I should say, of Sora's outputs, these images, are existing images. In other words, this system did not learn the world. It doesn't know what a Shiba Inu is, for example. But there are pictures, images of Shiba Inus, and probably images labeled, once again, by workers that enable the models to improve in output over time. Now, Aschenbrenner talks about the level of compute, because the idea is that if you just keep throwing more compute at the problem of developing so-called AGI, that what you will get is some sort of super intelligence. And this gets us back to the original statement about needing massive, supermassive amounts of electrical power. And of course, this leads to to another sensible question, which is, if you have to build enough electrical power to power another United States simply to achieve this thing, presuming that you can, is it worth it? Because don't we need power for other things? So let's go back to the main page here. So let's take a look at who this gentleman is, because one of the things that I like to do is, do an analysis of what people's motivations are. One of the things I like to do is analysis. Take a beat. One of the things I like to do is an analysis. For our posterity. Okay, here we go. So let's talk about motivation. Leopold Aschenbrenner, who's the author of the document that we have been reviewing, describes himself as a person who recently founded an investment firm focused on AGI with anchor investments from Patrick Collison, Nat Friedman, and Daniel Gross. And before that, he worked on the super alignment team at OpenAI. Alignment is supposed to align AI, allegedly, with human need. In a past life, I did research on economic growth at Oxford's Global Priorities Institute. Now, the point here is that when someone is making a statement to you, what I suggest you do is ask yourself the question, what is their motivation? Here, Aschenbrenner is giving us lots of bombastic statements, including statements later in this series about the free world must prevail, competition with China, and so forth, intelligence explosion. But he's part of an organization that has received funding and is no doubt looking for more funding. And what better way to get funding than to say that the thing that you're doing is of critical importance to humanity? One of the things that people talk about is Americans are very fond of saying that one shouldn't be cynical. But I think that we have an excess of belief, actually, not a lack. It is good to be cynical because you need to understand what people's motivations are. So if you founded an investment firm focused on AGI, of course you're going to be boosting the idea that AGI is possible. But here's the thing. Is AGI possible? Are you actually talking about something that can be accomplished? This brings me to my final example, which is this document written by the scholars that you see here, computational researchers, or rather cognitive researchers, who do actually an excellent job of challenging the idea of AGI and saying that there may indeed be value in algorithmic systems and what we're calling AI, but not in what is currently being done. Not in this, right, in which AGI is sort of tossed out as a possibility, or rather as an almost inevitability, but rather that we should be using these computational resources, and certainly not anything that requires you to build an entire new continent of power plants and corresponding data centers, using this to do research into the way we think, into logical structures, and other interesting scientific questions. Let me just read this, the abstract from this document. The idea that human cognition is or can be understood as a form of computation is a useful conceptual tool for cognitive science. It was a foundational assumption during the birth of cognitive science as a multidisciplinary field with artificial intelligence as one of its contributing fields. One conception of AI in this context is as a provider of computational tools, frameworks, concepts, formalisms, models, proofs, simulations, etc., that support theory building in cognitive science. The contemporary field of AI, however, has taken the theoretical possibility of explaining human cognition as a form of computation to imply the practical feasibility of realizing human-like or level cognition in factual computational systems, and the field frames this realization as a short-term inevitability. Yet, as we formally prove herein, creating systems with human-like or level cognition is intrinsically computationally intractable. This means that any factual AI systems created in the short run are at best decoys. Now, this is a really important thing to keep in mind. Decoys. Because what the GPT family of products is doing is producing plausible text, the very thing that Aschenbrenner here denies. He's saying that people who talk about how the systems actually work are the ones who are wrong, but the people who say that the systems can do anything and everything are the ones who are correct. But what's lacking from this is hard data. Hard data about how these machines work, what they can do, what their limits are, and what their economic and ecological costs are. I suggest that we spend more of our time learning from the scholars and the technologists and the practitioners who actually know how these systems work, rather than the individuals, such as our friend Ashenbrenner here, who want to make money.